Hello and welcome to G Fun Facts Online. Artificial intelligence can now write poetry, draft legal contracts, and even generate computer code. It's brilliant, but it has a deep, persistent flaw. It lies. Not maliciously, but with the unwavering confidence of an expert. This phenomenon is called hallucination, or more accurately, confabulation. And it's when an AI presents fabricated information as solid fact. The stakes are incredibly high. A hallucinated medical treatment could be fatal. A financial decision based on fake data could be a disaster. Some studies in 2023 estimated that certain chatbots hallucinate up to 27% of the time, with factual errors appearing in nearly half of their generated text. So today, we're going on an odyssey into the mind of the machine. Why does AI make things up, and what on earth are we doing to stop it? To stop the lies, we first have to understand where they come from. These aren't just random glitches. They are baked into the very design of modern AI. Let's break down the four main culprits. First is the architecture itself. Most large language models, or LLMs, run on something called a transformer architecture. Its superpower is a feature called the attention mechanism. Think of it like this. When you write an essay, your brain pays attention to the context of what you've already written to decide what to write next. The AI does the same, weighing the importance of different words to generate a coherent sentence. But this is also where things can go wrong. Imagine you ask the AI about a non-existent scientific paper on quantum physics. The AI's attention mechanism might light up with related concepts, real quantum physics ideas, the typical structure of academic papers, common scientific jargon. It then starts weaving these related but incorrect pieces together. It drifts away from the facts and confabulates a detailed, plausible, but entirely fake research paper. This is like a cascading error. A small mistake in an early thought process gets amplified as the AI tries to build a logical-sounding narrative around that initial flawed premise. The second major cause is something we can all understand. Garbage in, garbage out. LLMs learn by reading colossal amounts of text, mostly scraped from the internet. We're talking trillions of words. And as we all know, the internet is filled with misinformation, biases, and just plain wrong facts. It's impossible for humans to manually check all this data. So, if an AI is trained on an article that incorrectly states a fact, the AI learns that falsehood and will repeat it confidently. This is especially a problem for what we call long-tail knowledge, facts or topics that are rare in the training data. If the AI has only read about something once or twice, it hasn't formed a strong understanding and is more likely to hallucinate when asked about it. This also means an AI's knowledge is frozen in time. If it was trained up to 2022, it knows nothing about events in 2023 and might invent details to fill that gap. The third culprit is the AI's fundamental goal. We think of them as knowledge engines. But at their core, LLMs are prediction machines. Their entire training process is designed to do one thing: predict the next most statistically probable word in a sequence. It's rewarded for sounding plausible, not for being truthful. In a sense, they are always hallucinating, token by token, just stringing together what sounds right. The problem is, when these statistically likely but factually wrong sentences are presented as answers to our questions. This is made worse during a process called fine-tuning. This is when humans give the model examples of good answers to help it become more useful. But if a human-written example contains information the AI hasn't seen before, the model learns a dangerous lesson. When in doubt, make it up to match the style. Finally, the fourth and most foundational cause is something called tokenization. Before an AI can even read a sentence, it breaks it down into smaller pieces, or tokens. These can be words or parts of words. But how it breaks them up matters. An inefficient tokenizer might split a word in a way that creates semantic confusion, especially in languages other than English. This tokenization is the lens through which the AI sees our words. If that lens is warped, its entire understanding will be flawed from the very beginning. So it's not one single bug. It's a complex mess of architectural quirks, messy data, a flawed core objective, and the very building blocks of how it processes language. So if the problem is that deep, what can we do? Fortunately, the battle against hallucinations is being fought on multiple fronts with a growing toolkit of clever strategies. Let's start with one of the most powerful tools, Retrieval-Augmented Generation, or RAG. The easiest way to think of RAG is that it gives the AI an open book exam. Instead of relying only on its vast, static internal memory, which we know can be flawed, a RAG system forces the AI to first look up relevant information from a trusted external knowledge source. Here's how it works. When you ask a question, the system first retrieves snippets of text from a pre-approved database, like a company's product manuals or a collection of scientific papers. Then it combines your question with this retrieved information and feeds it all to the AI. The AI then generates an answer based on the facts it was just given. This is a game changer for things like customer support bots, which can now pull from up-to-the-minute policy documents instead of making up answers. But RAG isn't a magic bullet. Its effectiveness depends entirely on the quality of its open book. If the knowledge base itself contains errors, RAG will just serve up those errors with more confidence. The next strategy is something anyone can use: advanced prompt engineering. This is the art of crafting your questions to guide the AI towards a more factual answer. A simple trick is to start your prompt with "according to a trusted source like Wikipedia." This simple addition can improve accuracy significantly. A more advanced technique is called chain of thought prompting. You're essentially asking the AI to show its work. By instructing it to think step by step, it's less likely to jump to an incorrect conclusion. Taking that even further is chain of verification. Here, the AI generates an answer. Then you prompt it to create a list of verification questions about its own answer. Then it answers those questions, and finally it refines its original response. It's forcing the AI to double-check itself. Moving beyond just asking better questions, we have techniques that actually change the model's brain. One is fine-tuning. This is like taking a general-purpose AI and sending it to a specialized school. You can further train it on a smaller, high-quality dataset for a specific field like law or medicine. This gives it deeper, more accurate knowledge in that domain. But the real powerhouse of model training is reinforcement learning from human feedback, or RLHF. This is the technique that made models like ChatGPT so much better. In RLHF, humans act as teachers. They are shown multiple AI-generated answers and rank them from best to worst. This ranking data is used to train a separate reward model. Then, the main AI is trained again, but this time it gets rewarded for generating answers that the reward model predicts a human would like. It's a direct feedback loop that teaches the AI to align with human preferences, including a preference for truthfulness. Finally, a new frontier is teaching AI to be self-aware. This is the idea of self-correction. Researchers are developing methods where the AI generates a response, critiques its own work for potential errors, and then regenerates an improved, more accurate response, all without human intervention. This could be paired with automated fact-checking tools that cross-reference the AI's claims against reliable sources in real time. By combining all these strategies, grounding the AI in reality with RAG, guiding it with smart prompting, retraining its core knowledge with fine-tuning and RLHF, and teaching it to self-correct, we can begin to tame the digital muse. So where does this leave us? The quest to reduce AI hallucinations is one of the most critical challenges in building safe and reliable artificial intelligence. We've seen that the causes are deep, stemming from the AI's very architecture and training. But we've also seen a powerful and expanding toolkit of solutions, from open book exams with RAG to human-led training with RLHF. But this raises a profound question. Can hallucinations ever be truly eliminated? Some researchers argue, based on mathematical principles, that a completely error-proof AI might be impossible. There may always be a non-zero chance of a fabrication. If that's true, the goal shifts from curing hallucinations to managing them. The future is likely a hybrid approach, where adaptive systems intelligently combine multiple strategies at once. We'll see new model architectures designed for reasoning, and models that can learn continuously in real time so their knowledge never gets stale. But no matter how advanced the technology becomes, human oversight remains essential. We are the ones who curate the data, provide the feedback, and ultimately decide how these powerful tools are used. The journey is far from over. The next generation of AI won't be defined by its fluency, but by its truthfulness. The ultimate goal is not just a smarter machine, but a trustworthy partner in our collective search for knowledge and understanding. Thanks for listening to Fun Facts Online.